All right, so in my last video, I talked about the sine rule or the law of sines. There's one other tool called the cosine rule, the law of cosines. And then you've got really all the tools you'll need about triangles. So here is a quick uh, reason why the cosine rule works, and then I'll do an example. So if we start with just a random triangle, again, we're not assuming that it's a right triangle. We're just assuming that it is a triangle. What I'm going to do is just like in the previous video, just split it into two right triangles so I can use the things I knew about right triangles there. And so what I'm going to do is I'm going to call this H. And then remember, just like in the sine rule, the opposite side is the name of its opposite angle. So like angle B is on the top of the triangle, so this is called side length B. But really here, the letter B is kind of split up into two pieces. So I'm going to call that piece X, and then this piece is everything left over, B minus X. If you think about it, adding up those two pieces, if you add up this purple chunk here with this pink chunk over here, you can see that you're adding an X and adding B minus X, so that's why that adds up to the whole side B. Okay, so what we've got is just like in the last video, we've got a right triangle here. And what I'm going to do is try to figure out something about this side over here, which is given the name C. There's nothing really special about the side length C. It just will look similar to something that you've seen before if I use the side length C. If I use a different side length, then the letters will be out of order from what you've seen before. Okay, so what I can do is I can set up Pythagorean theorem. So I'm going to do this triangle here on the left. So if you look at this triangle here on the left, I can set up the Pythagorean theorem like this. A squared plus B squared equals C squared. Okay, so I just used H and B minus X as if they were side lengths there. And what I can do is I can write that out. I don't really need the parentheses there. Now B minus X squared, this is a little bit trickier, but squared means times by itself. So I just write it down twice like that. And then I'm going to distribute it. B times B times negative X times B, negative X times negative X. So I get X squared plus B squared minus BX minus XB plus X squared. Because the two negatives on that last one, negative X times negative X makes positive X squared. Okay. Now, what I can do here is set up, notice that this negative bx is the same as this negative xb. The two letters, it's like if I did 3 times 5 or 5 times 3, I get the same answer either way. So I can combine my like terms. So now I've got h squared plus b squared minus 2bx plus x squared equals c squared. All right, this has got a lot of letters going on here. So let's try to figure out some things. So when I look at what the letter H is, if there's anything else I can do with the letter H, what I notice is that there's another triangle over here on the right. So this triangle over here on the right is also a right triangle. And so I can set up a separate thing here that says h squared plus x squared equals a squared. And if I solve that for the letter h, because I have too many letters going on in this gigantic equation over here, I can get h squared equals a squared minus x squared. And I'm going to take that and substitute it in right there. And then things are going to start looking a lot nicer. I know this feels like a lot right now. So if I substitute that in right there, I get a squared minus x squared. And then I'm going to copy the rest of this equation down. Plus b squared minus bx plus x squared equals c squared. I hope you can see how something's going to clean up here. There's a negative x squared, and there's a positive x squared. So boop, boop, those disappear. And now I've got something that looks almost like something very familiar. A squared plus b squared minus 2bx equals c squared. Okay, we're getting somewhere now. That looks a lot like the Pythagorean theorem. One other hint here, just if you're trying to think ahead of what I'm doing, I called this the cosine rule, and I haven't even used cosine at all. So what I'm going to try to focus on now is if there's a way I can turn this letter x into something. And so here's the letter x, just for reference again. And I can set up the cosine of the letter c is equal to adjacent over hypotenuse. So I'm just looking at the purple triangle. Angle C is right here. So x is adjacent and a is hypotenuse. And if I multiply both sides by a, I get this really nice substitution. A times cosine of c is equal to x. Just going to grab that and substitute it right in there. And then we get the cosine rule. A squared plus b squared minus 2ba cosine c is equal to c squared. And so here's the idea. This rule works on any kind of triangle, whether it's a right triangle or not. It looks a lot like your a squared plus b squared equals c squared, but that one only works when you have a right triangle. Okay, so I'll give you an example here of using the cosine rule to try to find a missing piece of information. So let's say we've got a triangle ABC. So AB, we'll call that 7. And here's C, so we'll say 14 and 12. So I know that I can set up here a squared plus b squared minus 2ab cosine c equals c squared. So I'm just going to fill in, remembering that angle A is opposite of side length A. So A is 14, B is 12, C is 7. Notice that it's not the case anymore that C has to be the longest side. A, B, and C are just any sides on a triangle because we're not talking about right triangles anymore. So we have 14 squared plus 12 squared minus 2 times 14 times 12 cosine of C equals C squared. Okay, so 14 squared comes out to be, I think, 196. That sounds right. 12 squared is 144. 2 times 14 times 12. What does that come out to be? Let's double check that. 2 times 14 times 12 comes out to be 336 cosine C equals 49. So now I've got 144 plus 196. So I got 340 minus 336 cosine C. Now I'm going to take that 340 away from 49. So negative 336 cosine C equals negative 291. Divide 291 by 336. Cosine of C equals 0.866. And then I will, if you watched the last video, I talked about how you have that extra button on your calculator that looks like this. It's the same cosine button, but it has a little -1 on it. So you hit that button and type in 0.866, and it'll tell you the angle measurement. And so we know that C is 30.0 degrees. And so that's an example of using the cosine rule to find an angle. You can also use it to find a side length if you know two sides and one angle. So there you go. Please like or comment if there's anything else I can do to help.